Hi Year 11. Our next video is dealing with exercise 15b and it's looking at further binomial expansions. Now the rule that we're going to have a look at in expanding today is basically the same as what we saw last week, or last lesson, sorry, with our 1 plus x to the power of n expansions. We're going to have a look at today of a general rule for x plus y. So where we had a 1, we've now got an x or a y. We've just got two variables in there. And we're going to pay close attention to the pattern in the examples below. So we're still looking at Pascal's triangle. We're still looking at starting our rows at 0. And we're still working out coefficients from Pascal's triangle. And they're still going to be the same coefficients as we had before. But we're going to do something different with our variables inside our brackets here to the power of n. So if you have a look here. Here are the expansions of x plus y from n equals 0 to n equals 5. Now the red parts in our little triangle here are the same as up here in our triangle. So the red numbers are the coefficients. And the difference is from what we did before is we need to not only look at powers of x, we need to have a look at powers of y. So what we're generally doing, or the way I like to think of it, is we think of the x's decreasing in power and the y's increasing in power. But it doesn't really matter if it happens the other way around. But what happens, we might just start with the third row, actually. I think we'll have a look at x plus y to the power of 2. Although we know what that expansion is by squaring it ourselves, we've got our coefficients in red. And I'm going to start with my x's with the highest power. So our n here is 2, so my x is going to be 2. My x's are going to decrease by a power of 1 until I get to the end here, it's going to be x to the 0. At the same time my x's increase, my y's are going to decrease, or you can think of my y's as starting at the other end and increasing from right to left. But I'm going to do it as thinking of, we're going to start here with y to the 0. I'll just zoom in a little bit for you. So y to the 0, y to the 1, and then we have y to the power of 2. So they increase from either end, or you can think of one as increasing and one as decreasing. So we look at powers of 5, x plus y to the power of 5. We've got our coefficients for row 5. And we're going to start with x at the highest power at this end, y with the highest power at the other end, and we're going to move down. So x to the 5, x to the 4, x to the 3, x to the 2, x to the 1, and up here we'd have x to the 0, which is just 1. And maybe we'll start at the right. I'm going to start at y to the 5 at the other end, y to the 4, 3, 2, 1, 0. So 1 increases, 1 decreases. Now it doesn't matter whether we start with x to the 5 up here or at the other end. I normally just like to start at the highest power up here because we've got that first value being our x. So the rule is no different to last week. We're just increasing and decreasing both of our variables in the brackets. So we're going to use that to expand 2 plus x to the power of 3. So powers of 3 mean we need the row of the triangle that has a 3 in it. So our coefficients would be 1, 3, 3, and 1 for this one when we're expanding it. So 1, 3, 3, and 1. We need to look at powers of 3 being our highest. So I'm going to have 2 to the power of 3 at this end. 2 to the power of 2. I might pop that 3 outside the bracket just to be consistent. 2 to the power of 1 and 2 to the power of nothing. And then what we're going to do, well, we're going to pop the x value, which was our second variable in here, and it's going to pop in here and start at 0. So x to the 0, x to the 1, x to the 2, and then x to the 3. And we've got pluses in the center because we don't have any negatives in that question. And now we just need to neaten that up a little bit. So if I do that, I'm going to end up with 2 cubed is 8. And I've got x to the 0, which is 1. So I've got 8 plus 2 squared is 4. 4 threes are 12x plus 6x squared plus x to the power of 3. So there's that expansion, which with a power of 3, we could do other ways. And we could do that with a power of 4. But this gives us a nice quick way to expand. Okay, now this one, we just need to make sure that we're taking, when we do the x, the minus with that x as well. Okay, step 1 is I like to find the coefficients of our powers of 4 first, which are 1, 4, 6, 4, and 1. Again, you might get into the habit where you can do a term all at once, but I like to use that consistent method so that I don't make mistakes. So we're going to start first of all with 2, which is our first term in the brackets, and it's going to be to a power of 4. So we've got 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, and 2 to the nothing, which is just 1. And then I'm going to put my minus x's in, and we're going to start that with a 0, minus x to the 1, minus x to the 2, minus x to the 3, and minus x to the 4. And I'm just going to pop pluses in the middle now. And then when we deal with our powers, we can sort out that and neaten that up a little bit. Okay, let's work out what that's going to be now. Okay, so our first one here, we're going to have 2 to the power of 4, which is 16. Oops. And we're going to have a minus, a minus x to the 0, but anything to the 0 is 1. So that's just going to stay as 16 plus. Our next term is going to be 2 to the 3, and 2 to the 3 is 8, and 8 times 4 is 32. So I'm going to actually get rid of that minus to start with. I'm going to have 32, and we've got a minus and an x in there. And our next one is going to be 2 squared is 4, 6 fours are 24. The minus is squared, and we have an x squared. We're going to have 4 twos are 8, and we're going to have a minus because we're cubing that, and that still stays a minus. And our last one is going to be equal to plus x to the power of 4, and there's our expansion there. Okay, I'm going to work through the next one a little bit faster. We'll go and we'll pop the coefficients in to start with. Now we'll pop the 2's in, starting from power of 4 on the left-hand side. And now we'll pop our minus 3x in, starting with powers of 0 on the left-hand side. Okay, now we'll neaten that up. See if you want to pause the video and have a go at neatening your one up as well, and we'll check our answers. Okay, there's my solution there. If you've made a mistake and yours looks different, it's probably because you're forgetting in each of these brackets to, example, square the minus 3 or cube the minus 3. So go back and fix that up if you've made a mistake. Let's have a look at the next one. It says expand 2 minus 3x to the power of 7 as far as x squared, and hence find the term of x squared in this expansion here. So let's look at the first part. Let's expand this as far as the x squared term. So I've just expanded that until we've got to the term of x squared in there. So I haven't needed to write all the coefficients down. So I'm just going to neaten that up a little bit now. And then what it wants us to find out is what we would end up with is if we multiplied our 2 minus 3x to the power of 7 by 5 plus x. And it wants us to find the term of x squared. Now, we're going to get x squared, in 2 separate ways. We're going to get the x squared term that we already had down here, the 6,048x squared, and it's going to be times by 5 when we expand it out. And we're going to also get an x squared term, which comes from our x term when we multiply by the x. So we're going to have 1344x times by x, and that's going to give us these values. So I've multiplied these out, and I've got these 2 separate values. So we need to add these together to get our final value or coefficient of x squared. So we're going to get 28896x squared is our term for x squared. So the coefficient is 28,896, and that belongs to the x squared.